All right, today I'm going to take you through what we call the discriminant lesson. Discriminant is actually a calculation. It's called b squared minus 4ac. It's pretty easy to remember, so you'll have that in your head though pretty quickly. And it will help us to use the quadratic formula to solve quadratic equations that are not factorable. We can tell a lot from the discriminant. We can tell whether we have real number solutions or no real number solutions, imaginary or complex numbered solutions, which we're not going to get into here in this class. But it also can tell you whether you have a rational number for an answer, meaning an integer value, a number that can be written as a fraction, both positive, negative. It can tell us if we're going to have one solution where 0 would be our answer to the discriminant. And it can tell us whether or not we have irrational solutions. So that means anything that cannot be written as a fraction, such as a square root or a decimal that will just go on for eternity. Okay? So that's what the discriminant does for us. So first, we're going to memorize this over time. b squared minus 4ac is the discriminant. Okay, so what's b, a, and c? All right, remember the quadratic equation must always equal 0. All quadratic equations are written in the form of ax squared plus bx plus c. So we're going to take our first quadratic equation, okay, and it's x squared plus 5x plus 8 equals 0. All quadratic equations, again, must equal 0. If they don't, then you're not going to be able to identify the proper a, b, or c. So what we're going to do is we're going to pull the information off of this equation, and a is always the coefficient of x squared, or the squared term. So that's 1, because if you don't see it, it's 1. Otherwise, if you do see it, the number will be there. It can be positive or negative. That's fine. b is the coefficient of the x term, or the middle term, and you take the sign in front of it. Okay, so this would be a positive 5, because we're adding 5. And c will be the number alone that follows the middle term. Okay, so equals 0, equals 8 in this case because we're adding 8. So now to calculate the discriminant, we're going to take b squared minus 4ac, and we're going to substitute in with parentheses. That's really important because when you have negative signs for a, b, or c, that's going to be critical to put them in parentheses. So always put in parentheses. So b is 5, square it, minus 4, a is 1, c is 8. And now you can get your calculator out and calculate that. And you can put it in your calculator just like this, or if you're going to show your work, this would be 25 minus 32. Order of operations means we go left to right, and we're going to subtract these, and we're going to get negative 7. When your discriminant is a negative number, it means that you have two non-real solutions. So this tells us that we have two non-real number solutions, what we call roots. So you're going to hear questions of what is the root, okay, or how many roots do you have? And that's what it means, two solutions. So what this means is if we were to graph a quadratic equation, okay, this one in particular, we would have a vertex somewhere, as we know how to do that, negative b over 2a, we can find that. And it's not crossing the x-axis. So remember, whenever we're trying to find our solutions are where our parabola will cross the x-axis. If we have two non-real solutions because the discriminant comes out to be a negative number, then that means our parabola could look like this. It could look like this. It could look like this. Okay? And what you can see is they never cross the x-axis. And that's why we have what we call two non-real number roots or number solutions. Okay? So when your discriminant is negative, no real number solutions. It would be an imaginary number. All right, so let's take another problem. X squared plus 4x plus 3 equals 0. And we want to find the discriminant. So b squared minus 4ac is our discriminant. Okay, we need to identify a, b, and c. A equals 1. That's the number right here in front of the x squared. B equals 4. And c equals 3. All right, so let's plug in. We're going to plug in b, which is 4. We're going to square it. Minus 4. Plug in a, which is 1. And plug in c, which is 3. Squaring 4, we get 16. 4 times 1 times 3 is 12, so minus 12. And the 16 minus 12 is 4. And what we see here is that 4 is a perfect square. So if we took the square root of this, we would get 2. So it's a perfect square. So because it's a perfect square, this means we have 2 rational roots. Or 2 rational numbers for the solutions. And rational numbers can be written as a fraction. All right, so keep that in mind again. This is old stuff. That means can be written as a fraction. So you could get an answer for your 2 x-intercepts, your roots, your solutions, if you factored it, as 1 and 3. Or you could get a negative 1/2 and negative 1/4. Or you could get negative 7 and positive 1/2. All rational numbers. So when you have a perfect square for your discriminant, you have 2 rational roots. What they are, we don't know. We would have to factor and solve. But this tells us about the type of solution we're going to have. All right, let's try another one. All right, so we'll start with our next problem. It's 2x squared minus 5x minus 6 equals 0. I've pulled off a, which is 2, b, which is negative 5, and c, which is negative 6. And our discriminant is b squared minus 4ac. So we're going to substitute negative 5 in parentheses into b, then minus 4. We're going to substitute 2 in for a and negative 6 in for c. Now what's important is that you have to have this in parentheses because the meaning, okay, we discussed before, the quantity of negative 5 squared means negative 5 times negative 5, which is going to give you a positive result of 25. If you don't have that in parentheses, even your calculator will give you the incorrect answer because it won't know any better. Okay, so you are the brains behind the operation here. So this is 25. Now, if I cover that up, it looks like I have a negative 4 times a positive 2, which is negative 8, times a negative 6. So when I have the minus sign and a negative, one negative in the calculation here, that means plus. So this is going to be 24 times 2, okay, which is going to give us 48, okay. And so we're going to put that together. Also, you can do it as negative 8 times negative 6, and that's positive 48. And then we're going to calculate 25 plus 48, which is going to give us 73. Now, 73 is not a perfect square. However, it's also not a negative number, so we're not going to have non-real numbers. We're going to have a real number here, okay? So whenever this is greater than 0, this discriminant, then, and it's not a perfect square, okay, that's important. It's not a perfect square, okay? It is greater than 0. Then what we're going to do is we're going to have 2 real number solutions, but they're going to be irrational number solutions, or roots that we call them. Okay, and we'll put that in parentheses as solutions. So whenever this discriminant is greater than 0, like we saw on the last one, was 4, but that 4 was perfect square, so we had 2 rational numbers. Now we have 73. It is greater than 0. It is not a perfect square. So therefore, they have 2 real numbers that are solutions, but they're irrational. So that's what the discriminant tells us. It's really a pretty powerful little formula to remember to tell us what kind of answers are we going to get if we were to factor our quadratic equations. What are our x-intercepts going to be? This is going to tell us what kind they are, not where they are. okay? All right, okay, and we have one more, which is x squared plus 4x plus 4 equals 0. And if your equations don't equal 0, you're going to have to add or subtract to get everything onto the left side so that it does equal 0. Just keep that in mind, okay? So let's strip off our A, our B, and our C. All right, so discriminant is b squared minus 4ac. We're going to put in parentheses our b, which is 4, and square it, minus 4, in parentheses a, and in parentheses our c. 4 squared is 16. 4 times 1 times 4 is also 16, so it's minus 16. So the answer for this discriminant is 0. When your discriminant is equal to 0, that means you only have one real number solution, and it's rational, okay? So that's what this means. It's a one real number root, and it is a rational number. And the reason it's a rational root is that that means we're going to have, it can be written as a fraction. It won't be a square root of 2. It won't be a square root of 3. It could be a square root of 4, which comes out to 2. Okay? So all this means for us is that where we cross the x-axis, where our parabola will cross the x-axis, is going to have only one solution, okay, for the x-intercept. In other words, this parabola has a vertex that will sit on the x-axis. This would be our one real root right there. Maybe it's going downward, okay? Doesn't matter if it's going up or down, but where it sits on the x-axis is only one. So when your discriminant comes out to 0, you have one real number root, it is a rational number, and it just means the vertex is sitting on the x-axis, all right? That's why you only have one root. That would be a rational number. All right, so just to recap, okay? When your discriminant equals 0, if it equals 0, you have one real rational root. When it's greater than 0, you could have two answers possible here. One is a perfect square. And if it's a perfect square, you have two real rational roots. If it's greater than 0, but it's not a perfect square, we have two real irrational roots. Again, we won't know what those values for the roots or solutions are. This just tells you what kind you have, type. Okay? And if it is a negative number, those are the three things that can happen for your discriminant. If it's a negative number, you have no real roots. What this means is it is an imaginary number, and we're not going to be doing that this year, but you will in Algebra 2, so you know that they exist. It's kind of ironic that imaginary numbers exist. Okay, so that sums up the discriminant. Go back over this as many times as you need to watch as you do work, and compare your discriminant values to whether it's equal to 0, what kind of answers you're going to have, greater than 0, perfect square versus not perfect square, and what kind of answers you will have, and if it's a negative number, and what kind of answers that you will have if you were to solve the quadratic equation, which we're not doing here. We're just using it to tell us what kind do we have. All right, and that's it for today.